This is a video for lesson 4.6, reasoning about factoring polynomials. We've seen different types of polynomials, and for each of them there were different strategies that you could use to factor them. So what we're going to do today in this video is we're going to summarize the different types of polynomials, take a look at the different tips that there are when you're presented with a polynomial to factor. There'll be a separate appendix video that goes with this one here that basically has a flow chart that will go over all these tips that we have here. But in this main video, I'm going to kind of go over them verbally, and then afterwards I'll do some examples of factoring, how to use these tips to help make our factoring lives a little bit easier. And then afterwards we're going to take a look at some word problems involving polynomials and factoring and try to connect them to different contexts. So before you get to this video, it's important that you've done all the other videos and that you've done a lot of practice with factoring and the different types, and then things will make a lot more sense here. And like I said, please go and take a look at the flowchart video that will complement or supplement this lesson as well. So the first tip whenever you're given a polynomial to factor is to look for a greatest common factor, the GCF. So don't forget to do that. If there is a GCF, then what you should do is you should factor it out. It makes things a little bit easier for you. So if there is a GCF, factor it out. Okay, that's important. Now, our next step, so let's say there is a GCF, or there isn't, doesn't really matter. If the expression has two terms, then let's take a look to see if it's a perfect square. So we'll look for a minus sign. And perfect square. And that can make things a little bit easier when it comes to factoring. So two terms, look for a minus sign and perfect square, and then you can go with the strategy from there. If the expression has three terms, let's check to see if it's a perfect square trinomial. Perfect square trinomial. I'll just write it SQ. If the expression has three terms and an a that's equal to 1, then it's a simple trinomial. And those are pretty straightforward to factor. All you have to do is make sure you look for two numbers that have product of C and sum of B. If the expression has three terms and A is not 1, then you have more of a complex trinomial. And so what you need to do is look for two numbers that have product A times C and sum of B. So hopefully this is sounding familiar and it kind of makes sense to you as we go through it. We've seen these types before. We're just kind of summarizing all of the different types that exist. And now sometimes we have situations where the expression might have 4 or more terms. And if that's the case, what you want to do is look for groups where there's some commonalities and then factor. So quick recap here. So the first step is you want to look for a GCF. If there is a GCF, then make sure you factor it out, because that'll make things a little bit easier. It might create a polynomial that's a lot easier to factor. If the expression has two terms, then what you want to do is you want to look for a minus to see if we have a perfect square and difference of squares. If the expression has three terms, check for a perfect square trinomial. That could really simplify your life a little bit. as we learn a technique for perfect square trinomial that makes things a lot easier. If there's three expressions and the a is equal to 1, then it's just a simple trinomial, and you just have to kind of do that trick where you look for two numbers that have the product that's c and the sum that's b. So two numbers that will multiply together to give you that last term at the end, that constant, and when you add them up, they give you that term in front of the x, not x squared, but the x. If there's three terms and a is not 1, then that means you have your complex trinomial, and you have to do that trick where you multiply the c value by the a, and you want to find the two numbers, the products, where the product will give you a times c, and the sum still gives you b, and then maybe you could use decomposition if you need to. And then if there's 4 or more expressions, then you want to look for groups that have some factors in common, and you want to factor those out, and that can make things a little bit easier as well. Sometimes doing one step can lead you to figuring out that you might have a difference of squares, you might have a perfect square trinomial when I factored the greatest common factor out. So always start off with that first step of greatest common factor, and then things just open up. It's not always apparent, but it kind of opens up like a puzzle. The more pieces you kind of fit together, the more clear that picture becomes. So let's do a few examples of factoring together and see what they fall under based on the tips that we have here. So here we have a polynomial, and we have three terms. So we have three terms, and it looks like our a over here, if you look at question a, the value in front of the x squared is just a is equal to 1. So this is a simple trinomial, and we just want to find a product and a sum. So two numbers that when you multiply them, you get negative 132, and when you add them together, you get positive 1. So let's think about that. If you do, so we want negative 132. I know that 12 times 11 is 132. So the thing is, it can't be 12 and 11 because their sum is 23. So we might have to change the sign of those numbers. So let's try negative 11 times 12. That would definitely give you negative 132. And negative 11 plus 12 would give you 1. So it looks like negative 11 and 12, those are our two numbers. And so what we would do is we would create our little brackets here. And then we put our x's in there. And we put negative 11 in one and positive 12 in the other. Doesn't really matter where you put which one, as long as you have those written down like this. The order doesn't matter. Like I said, you could have x plus 12 here, x minus 11 here. It would have been the same thing. It's like saying 2 times 3 or 3 times 2. They're the same thing when it comes to multiplication. So we're able to spot this as a simple trinomial. Let's go to example B. Example B, when I have all these big numbers here, I like to see if there's a common factor I can take out. And right now it doesn't look like there's a common factor. I'm just looking at 16 and 121. It doesn't look like there's a greatest common factor, whole number that I can take out of this. So that makes things a little bit difficult. I'm going to check to see, because I have 3 terms, I'm going to check to see if I have a perfect square trinomial. That might save me some time. So let's take a look at 16 here. 16 is a perfect square, because if you take square root, it's 4. 121 is a perfect square. So that works out. But now let's take a look if the middle actually ends up being minus 2ab. So remember that a is a square root of the term here. So it would be minus 2 times 4. And then b is a square root of the last term here. So 11. And that would end up being minus 2 times 4 is minus 8, times 11 is minus 88. So all the conditions are satisfied. This is a perfect square trinomial. So what I can do is I can create my bracket. I can square it like this, and then remember you take the square root of the first term here, so that's the square root of 16x squared, which is 4x, and then the square root of the last term there, square root of 121 is 11, and then we put a minus or a plus depending on what the sign is here, and here it's a minus, so we put a minus there, and so we get 4x minus 11 squared. In other words, it's 4x minus 11 multiplied by 4x minus 11. You could have done the more complex method of finding a product that's finding two numbers where the product is 16 times 121, and when you add them up, they're negative 88. That would have been difficult, especially with decomposition happening there. So that's why I just wanted to save some time and do that perfect square trinomial check first, and it makes things a lot easier. So I did check first to see if there was a greatest common factor. I didn't see that, so I saw there were 3 terms, not 2 terms, so number 2 didn't apply. And since there were 3 terms, perfect square trinomial criteria were met, I was able to use this trick and solve it much more efficiently than I would have otherwise. Let's go to question C. So for question C, again, my first step is going to be to see if I can take out a greatest common factor. And it looks like I can in this case. It looks pretty good. I think 2, definitely coefficient would be 2. I'm going to take out a negative 2 just so I could make this x term here positive. I'm going to take out a negative 2 as a coefficient, and then as a variable, definitely x is shared with them. And how much x can I take out? Well, it looks like I can take out up to x squared. I can't take out more than that because this has x squared only. If I took out x cubed, then I'd have a negative exponent, and I wouldn't want that. So I'll take out negative 2x squared. And what that means is I'm dividing every term there by negative 2x squared. So it'll be 9x squared, because negative 18x to the power of 4 divided by negative 2x squared is 9, and then x squared. And then 32x squared divided by negative 2x squared, that's going to be minus 16. And x squared divided by x squared cancels out, so that's going to be just no more x. It'll be just minus 16. And what you'll notice is that you now have a situation where in the bracket you've created something with 2 terms. You've created a polynomial with 2 terms, and maybe, and we can see a minus sign here, maybe this will end up being a difference of squares. So let's take a look if that's the case. So is 9x squared a perfect square? It is. If you take the square root, it gives you 3x. Is 16 a perfect square? It is. If you take the square root, it gives you 4. So what we have here is negative 2x squared. Since we have a difference of squares, we can do open up our brackets like this. X over here, or not x actually, we take the square root of the first term, so 3x over here. 3x over here, that's square root of 9x squared. And then square root of 16 is 4. And remember, our trick is that we put minus in one bracket and plus in the other bracket. I just want to double check to see if I can factor anything else out from here. It doesn't look like it. So we've factored as much as we can in this situation over here. So notice, taking out that greatest common factor first allowed me to use another trick later on to make factoring a lot easier. Otherwise, this would have been very difficult to do on its own, and may have required other more complex strategies. So now we'll take a look at D over here. And again, I'm going to try to take out a greatest common factor first. It doesn't look like I can take out an x as a common factor because not all the terms in here have x. You'll notice this one here is a y. But I can take out a y. They all share y in common, and the smallest unit of y I can take out, or largest unit of y I can take out, is just y to the power of 1. So I'm going to rewrite this as y, and I'm going to take out y from each term. So x5 plus x2y2 minus x cubed y2 minus y4.